on pages 48 and 49 of our textbook, starting Unit 2, which is linear functions, equations, and their algebra. Unit 2 is only 5 lessons in length. The first 2 lessons you have seen before in Algebra 1 and in Geometry. So starting off with a bit of review from Algebra 1 with our topic, average rate of change. Average rate of change for a function of a domain x going from A to B, the function's average rate of change is calculated by the change in output over the change in input. And it has to be in that order. The output, change in output is the numerator, change in input is the denominator. And when we're talking about an x and y axis and points, the change in output is our change or difference in our outputs, our y values, divided by our difference in inputs, or x values. The change in f over the change in x. Change in outputs over change in inputs. In other words, if our interval is from A to B, it's going to be f of b. You evaluate the function for b, subtract, evaluate the function for a. So f of b subtract f of a divided by b minus a. So it's very important because it gives us a way to quantify how fast a function changes on average. So exercise number 1, we're going to calculate the average rate of change over the 3 intervals that we have listed here. So we're referring to this graph, and let me place some numbers here. Looks like it might be 15 by 15. Whenever there is no scale indicated, it is going by ones. So our first interval, x is going from 0 to 4. That means we want f of 4 minus f of 0 divided by our input values, 4 minus 0. Okay, f of 4, an input of 4 has the output 7, minus f of 0, input of 0 has the output 1. 4 subtract 0 is 4. So 7 minus 1 is 6. 6 divided by 4 reduces to 3 over 2, or simply 1.5. Next, we want the interval from 4 to 7. F of 7 minus f of 4. It's my habit to always start with the value that is on the right-hand side of the interval, because that's always the larger value. Can you do f of 4 subtract f of 7? Yes, as long as in the denominator you're consistent in that you would do then 4 subtract 7. Right, but continuing here, f of 7 minus f of 4, f of 7 is 10, minus f of 4 was 7. And let me go back, and the denominator would have been 7 subtract 4, which is 3. So 10 minus 7, 3, divided by 3 is 1. And our third interval, x is going from 7 to 13. So those x values make up our denominator, 13 subtract 7, and our numerator is f of 13 subtract f of 7. Our denominator makes up our outputs. So an input of 13, the output is 15. And the input of 7, our output was 10. And 13 subtract 7 is 6. So we have 5, 6. Which interval has the greatest rate? The greatest rate is the largest of these three, which is the 1.5 value. So it is this interval has the greatest rate. Then B asks, using a straight edge, draw lines by connecting the points shown on the graph. The average rate of change gives a measurement of what property of the line? Okay, so switch back to green. And we're connecting the first 2 points using a straight edge. Our next interval from 4 to 7 is in purple. So these 2 points here. Oops. Come on. And 7 to 13 was and what we've drawn here are the slopes connecting the 2 points. And you can see that the green one, right, has the steepest slope. So it's the one that's changing the fastest. So the average rate of change gives a measure of what property of the line? The steepness or slope of the line. And I bet you recall from geometry, in order to find slope, change in y over change in x. Remember this formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Exercise number 2, consider the two functions. We have f of x equal to 5x plus 7 and g of x equal to 2x squared plus 1. We want to calculate the average rate of change for both functions over the following intervals. Okay, so let's see. Over the interval from -2 to 3, so I'll do f of, this stays, there we go. F of 3 minus f of -2 divided by 3 minus -2. Okay, now for f of 3, it does say to show your work. That means we have to put 3 in for x here. So I'll do it here. That's 15 plus 7, I believe is 22. Minus f of -2, put -2 in for x. 5 times -2 is -10, plus 7 is -3. And 3 subtract -2 is 3 plus 2, which is 5. That's 25 divided by 5, which is 5. I'll use a different color for our g of x. So now I want g of 3 minus g of -2 divided by 3 minus -2. G of 3 is 2 times 3 squared. 3 squared is 9, times 2 is 18, plus 1 is 19. And g of negative 2 is 2 times negative 2 squared is 4, times 2 is 8, plus 1 is 9. And the denominator, 3 minus negative 2 is 5. So we have 10 over 5, which is 2. Now, back to f of x for this interval from 1 to 5. F of 5 minus f of 1 divided by 5 minus 1. F of 5, 5 times 5 is 25, plus 7 is 32. Minus f of 1, replacing x with 1, 5 times 1 is 5, plus 7 is 12. And 5 subtract 1 is 4. So this is 20 divided by 4, which is 5. And g of 5 subtract g of 1 divided by 5 minus 1. G of 5 5 squared is 25, times 2 is 50, plus 1 is 51. And g of 1 squared is 1, times 2 is 2, plus 1 is 3. That's 4. 51 minus 3 is 48. Divided by 4 is 12. The average rate of change for f was the same for both I and double I, but was not the same for g. Why is that? Well, let's look at f. All right, what type of function is f? F is a linear function. Its average rate of change is a constant. Right? In fact, that is, if you think of f of x, you can replace as y, right? Y equals 5x plus 7. The slope here would be the 5. Remember from algebra 1? That's the slope. Think of y equals mx plus b. That's our slope. And that's exactly what we calculated. Our average rate of change was 5 for function f. Whereas function g, what type of function is g? G is a quadratic function. Its average rate of change is not a constant. Exercise number 3, the table below shows the hours of daylight on the first day of each month in Kingston. Given the data, what is the average rate of change in hours of daylight per month from June to December 1st? So we want from June to December 1st. Okay, so it's going to be the change in hours over the change in month. Alright, so I'm going, starting with December. Hours is 9.0 minus then June 15.4. divided by December is the 12th month, and June is the 6th month. So 9 subtract 15.4 is negative 6.4 divided by 6 is negative 1.06 repeating, and we want to round this to the nearest tenth. So that's negative 1.1, right? The zero's in the tenth place, so we look to the right. 5 or larger, we round up. So negative 1.1 hours per month is our answer. Interpret what this means in the context of the problem. Okay, on average, the average rate of change, sorry about that, on average, the average rate of change in hours of daylight per month from December, I'm sorry, it's from June to December. Is a decline of 1.1 hours per month. And I use the word decline to indicate the negative. Okay, that finishes our lesson for today. Thank you very much for your attention.